Hi, this video is the follow-up to the previous video on balancing redox reactions in acidic solution by the ion-electron method. If we begin by balancing every redox reaction as if it's in acidic solution, we sometimes need to convert the result if the reaction actually occurs in basic solution. Instead of learning a completely new method, it's easier to learn how to convert the previous result using these few steps. All we need to do is to add hydroxide to the side that contains hydrogen at a 1-to-1 ratio. If one side has 6 hydrogen ions, we simply add 6 hydroxide. Then in step 2, just like in math, in order to keep our equation balanced, we add an equal number of hydroxide to the other side. In step 3, to the side that has both hydrogen and hydroxide, we convert them to water. In step 4, we adjust our water as necessary. And in step 5, like in any other part of balancing a redox reaction, we always check at the end. And if the equation is balanced for mass and charge, we know that it's right. So if we take the result from our previous video, this is a balanced equation, a balanced redox equation in acidic solution. I want to convert it to basic solution. So I notice that the left-hand side has 16 hydrogen ions. I simply add 16 hydroxide, and I add 16 hydroxide to the other side as well to keep everything in balance. Now, the left-hand side has both hydrogen and hydroxide, and anytime that happens in water, they're just going to neutralize and to make water anyway. So I really have 16 water here. And of course, the reaction already had 8 water on the right-hand side. So my next step is to fix this situation with the water. I get rid of the 8 water and subtract them from the 16, and I have a net of 8 on the left. Now, at this point, I don't see anything else to fix, so I'll rewrite the equation with 8 water on the left. Everything else remains the same, except for the 8 water that are gone on the right. Now, if my solution is correct, I should have it balanced for mass and charge. So I'll notice here that I have 8 times 2, 16 hydrogen on the left, and 16 hydrogen on the right. I have 8 oxygen here, another 8 here, that's 16, and 5 fours are 20, that's 36. I have 20 oxygen here, and 16 here is 36 on the right as well. So my oxygen is balanced. I have 2 manganese, and 2 manganese, and 10 carbon, and 10 carbon. All my atoms are balanced. Now I check my charges. I have 2 negative and 10 negative. I have 12 negative on the left. I have 2 times 2 is 4 positive and 16 negative. I have a net of 12 negative on the right as well. So it's balanced for charge as well. Because it's balanced for mass and charge, I know my solution is correct, and now it's been converted to being balanced in basic solution.